Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to M.I.B Multipurpose Lab. Today we are going to continue with our lesson of vectors, and the subtopic of today under vectors is resolution of vectors. Resolution of vectors. So resolution of vectors. When we say resolution of vectors or the resultant of a vector, the resultant of a vector is the sum of that vector. When you sum two vectors together, depending on the directions of the vectors, what you get is called the resultant of a vector. But to explain this resolution of vectors in an easy and simple way, very precise, I will use a flow chart, or let's say a diagram, a summarized diagram, block diagram, to explain this. Whenever you are given two or more vectors, let's start with two vectors to find their resultant. The first thing you will do is to check for angle. If you are given two vectors, check whether those vectors makes an angle with each other. That is, let me explain this. The vectors might be, this is vector 1, let's call it F1, and this is vector 2, let's call it F2. You can see these two vectors does not make an angle with each other. Then we can have another vector, let's say this is vector 1, which is F1 again, and vector 2, this is F2. So you see these two vectors makes an angle with each other. This one does not make an angle with each other. So you check whether the vectors have an angle, they made an angle with each other. This is divided into two. If they do not make an angle with each other, which means that is no. If those vectors does not make an angle with each other, the next thing you will check for is the direction of the vectors. Is the direction of the vectors. You check for direction. Now, if you are checking for the direction, this will be divided into two. If the direction, they are traveling in the same direction, the two vectors have the same direction. So the two vectors have the same direction, then the resultant is equals to the sum of the two vectors. It's equals to the sum of the vectors. This is what we have. And if those vectors, they are traveling in opposite direction, then the resultant will be equals to the difference between the vectors. This is what we have. So this is the block diagram. Whenever you are given two vectors to find their resultant, you check whether they make an angle with each other. Like I explained, you can see this is vector 1, two forces, for example, F1 and F2. They do not make an angle with each other. And this is another example of vectors that makes an angle with each other. So if they do not make an angle, that is, if it is no, we check for the direction of the vectors. If they are traveling in the same direction, their resultant is sum of the vectors. If they are traveling in opposite direction, then their resultant is the difference of the vectors. In simple sense, it means that you only add two vectors when they are traveling in the same direction, and you subtract two vectors when they are traveling in opposite direction. So now let's go back to the flow chart from the beginning. You check for angle. If they do not make an angle with each other, which is what I categorize here as no, like here, you check for direction. If the direction is the same, the resultant is the sum. If it is opposite, the resultant is the difference between the vectors. Now, what will happen if the vectors make an angle with each other? That is a yes. If the vectors make an angle with each other like this, for example, So if the vectors makes an angle with each other, the next thing how to find the resultant is you resolve the vectors. You resolve the vectors. And by resolving the vectors, that means you will find the resolution of those vectors. And you can do that primarily, you can do that using two ways. The first one, using the triangle method, the triangle method. And the second one is using the parallelogram law of vectors. Law of vectors. So this is what we have. This is just the overall flow chart of the resolution of vectors. Check for angle. If no, direction, the same direction you add, opposite direction you subtract. If they make an angle with each other, you resolve the vectors either using the parallelogram law of vectors or the triangle method. Let's take an example with the first case. Let's take an example with the first case. Example. Example, let's see. We have example. Let's do this is a vector. This is another vector. Let's assume this is F1, a force applied on an object, 10 Newton, and this is F2. Let's say this is 11 Newton. Now, you are asked to find the resultant of this vector. You are asked to find the resultant of F1 and F2. So you are asked to find the resultant of these two vectors F1 and F2. Now let's look at our flow chart. Do they make an angle? No, there is no any angle between F1 and F2. Therefore, what should we check for? Direction. The direction, is it the same or opposite? Looking at the arrowheads, this vector is going this way, the other one is going this way, which is the same direction. Therefore, their resultant will be the sum of the vectors. Hence, now our resultant R will be equals to F1 plus F2. And F1 is 10 Newton, then plus F2, which is 11 Newton. And this is equals to 21 Newton. That's all. Now, how do we draw this resultant? Since it is positive, it will be drawn like this. If this is F1, let me just sketch it for you, and this is F2, then the resultant will be a vector here, which is R equals to 21 Newton. That's all. This is the resultant of the vectors. Let's call this example 1. Let's take example 2. If we have, let's say this is another force F1 equals to 8 Newton, and this is F2 equals to 6 Newton. See, the vectors are traveling in the opposite direction. So if you are asked to find F1 minus F2, it's very simple. F1 minus F2 will just be equals to F1 is 8 minus F2, which is 6, which is equals to 2 Newton. And also, let's assume you want to find F2 minus F1. F2 minus F1, this is equals to 6 minus 8, which is equals to minus 2 Newton. You can see when vectors are traveling in opposite direction, F1 minus F2 is not the same thing as F2 minus F1, which means this is the resultant of the vectors F1 with respect to F2, and this is the resultant of the two vectors F2 with respect to F1. The one with the negative sign, don't say that if you see negative sign after calculating the difference between vectors, the answer is incorrect. No, that's not the case. Whenever you see negative, it's just showing the direction of the resultant. For F2 minus F1, it will look this way, and for F1 minus F2, it will look this way. Thank you. This is where we'll stop for this first part of resolution of vectors. The next videos will be on the parallelogram law of vectors, how to resolve vectors, and from them we'll go further. Don't forget to subscribe for more videos. Thank you. And also, yes, I want to remind you, don't forget, this is coming from M.I.B Multipurpose Lab. Feel free to drop a comment, suggestion, or advice, even correction if found. This is an academic environment. We are all here to learn.